Oscillation. What are the oscillations? In day-to-day life, when the fan is rotating, the page of the book is moving up and down. That is, we can consider as an oscillation. A branch of tree is moving to and fro. We can consider it is oscillation or a vibration. Okay, so what is the oscillation? First of all, we need to know. There are so many objects will move, but the moving must be repetitively. Okay, must be to and fro. Any object which is moving to and fro is called as oscillation. Sir, you will get immediately the doubt. What is the vibration, sir? Have told so many examples till now. Any branch of tree or surface of the water in a beaker, when you are taking, it moves up and down, right? If you take a bucket full of water, when you keep, the water will move or oscillate. This is all comes under the oscillation. They are to and fro, is moving. Okay. Then what is a vibration? Vibration is also a to and fro motion. But in vibration, oscillation you will find. Okay? In vibration you will find the oscillation. But in oscillation you cannot find the vibration.
Okay.
Means, for example, I'll take a scale and press it, I'll pluck it, it vibrates. A guitar string vibrates. Okay? Whenever I'm hitting an object, the object gets vibrated. A dome is vibrated. So these are vibrations. In vibration case, the particle will move very faster and rigorously. But oscillation which takes place with the small angle. Whatever the to and fro motion which takes place with the small angular displacement, such type of vibration or such type of to and fro motions can be called as oscillation. Let me tell you, this is a simple pendulum. It is oscillating. This is a small angular displacement. This is very small. How much small? In the sense, less than 10 degrees. Less than 10 degrees is a smaller vibration, a smaller oscillation. So that's why this is to and fro motion with a small angular displacement is called as oscillation, and this is called as vibration which takes place with a larger displacement from its mean position. Right? Now you got an idea what is this. Next, here we need to discuss some important terms. What are the important terms which we need to know here clearly? Periodic and oscillatory motion. What do you mean by periodic motion? Periodic motion. Simple logic, I'll tell you. In day-to-day life, we are the students in school. We have first period, second period, physics period, chemistry period, like that. Means, why we call it as physics period, chemistry period, maths period? Because the each duration of time interval is repeating same. With the same amount of time it is repeating. That's why that is called as periodic. If any motion which repeats in the equal intervals of time, or the repetitive motion in the equal intervals of time, is called as periodic motion. Okay? Now, oscillatory motion. What is the difference between oscillatory motion and periodic motion is here? Can anyone? Oscillatory motion or periodic motion?
Oscillatory can be periodic, but periodic motion need not be oscillatory.
Yeah, very good. All the oscillatory motions can be taken as periodic motion. All the periodic motions may not be oscillatory motion. Oscillatory motion means it must be to and fro. Okay, we will take it further, that is also through mean position. But coming to the, it might be periodic. But all the periodic motions may not the oscillatory motion. If you see a few graphs with respect to the periodic motion as well as the things, we are having here a few graphs. Displacement is a function of time. X of t means displacement is a function of time and with respect to the time. Here there is a sawtooth wave, means the object is moving up and down because a ball is throwing from certain height, it is doing jumps up and down. So therefore what is happening, in the given amount of time it has moved some height or some distance. With respect to s equal to ut plus half a t square equation, we can find the relation for that. Here it is repeating, but it is not the oscillatory motion. It can be considered as periodic motion. Same way, one more is there. We have displacement is a function of time, x of t. That also we can say it is as up to here. With respect to time, if you are taking the same amount of time interval it has taken, but it has raised at certain time and it has comes down. Means it coming to the mean position. Then again it is 0. Then again raised. Again it is in the mean position. Means here it is taking some duration of the time. Here also duration of the time. But the same thing is not happen in this and in this. In this case, let me tell you example, a ball if you are hitting, it will like a basketball, if you are hitting up and down, it comes with respect to time period, it raised and it has moved certain distance and comes back. But in this case, the ball is at rest initially. Okay, after certain time it starts moving up and again remains constant and coming to zero position. Okay, this is we have to apply ourselves into examples. Then one more example with the displacement versus time. Displacement is a function of time. In this case, sudden rising and sudden falling at the same time period, like this. Here also same duration of the time period. Means when you understood that when you are taking same equal interval, if you apply in all the cases, is the thing is happening same way? No. So with respect to the same interval of time, same periodic motion if you are taking, all are maybe periodic motions but not the oscillatory motions. This graph we can understand here. Now, oscillation and vibration we discussed, no? Next, period and frequency. Periodic motion already we have discussed. What is a periodic motion?
Repeated times.
The repetitive motion is called as periodic motion. Simple. Next, what is a time period? What is a time period? Time taken for one complete oscillatory or vibratory motion is called as time period. Time taken for one complete oscillatory or vibratory motion is called as time period. Time period units usually we will use in SI unit seconds. Okay, seconds. Now, time period is always inversely proportional to the frequency. Inversely proportional to the frequency. What is the frequency? What is the frequency? This is the most important word ever in physics. All the chapters. Maximum. Frequency. Frequency symbol nu or f or sometimes small m can be preferred to use. Number of vibrations or oscillations per unit time is called as a frequency. What is that? Number of oscillations or vibration. Oscillations or vibrations per unit time is called as frequency. For example, here I am considering for one oscillation. For one oscillation, I am writing f equal to 1 by the amount of time period is t. Time period. Okay. So this is frequency. Units for the frequency is SI unit directly we have to write as a hertz. Hz. Okay. And or second inverse, but prefer to use hertz always. That is a frequency case. Next, Here we have a question in that case. What is the question we are having from NCRT? On an average, human heart is found to beat 75 times in a minute. On an average, a human heart is found to beat 75 times in a minute. In a minute. Calculate the frequency and time period. Calculate the frequency and time period. First, you need to know the frequency in the sense, the question you need 75 times in a minute it is happening. Beat is in the sense heartbeat, lap da, lap da. Okay, means it is oscillating 75 times. So 75 oscillations or vibrations
By one.
per unit time. How much? 1 minute means 60 seconds. How much it gives us? Around 1.25
Meter per sec. Plus minus.
second inverse you have to say, or hertz. This is the frequency. Now I got the frequency. What you will ask? Time period. Frequency, if you know time period, you will get automatically. Time period equal to 1 by frequency, that is 1 by 1.25, which is gives us 0.8 seconds. Okay, this is time period and frequency.